Hey guys, today we're going to look at Git, but before we get into Git, there is a fundamental lesson that we're going to learn, and that lesson is how to learn. So before you learn any new technology, what you need to ask yourself is, what problem is this technology really solving for you? If you're not able to answer that question, what problem is this technology really trying to solve for you, you better stay away from it, because if you go ahead without knowing the problem that it's going to solve, what you're going to get is you're going to get syntaxes. And you'd get lost with those syntaxes, not being able to understand where and why and how to use those syntaxes. So as usual, which I would follow up in each and every course going forward, we will try to see very briefly what problem is Git trying to solve for us, or what problem is any new technology that we're going to learn will solve for us. So let's look at for Git, what problem is it trying to solve for us? Any location which is a remote for you. So if this is you, and if you're cloning a repository from me, for you, I am the origin. If I'm taking it from a server in America, then for me, this server in America is the origin. So remote for me is my origin, remote for you is your origin, so on and so forth. Try to understand what benefit does a distributed source code manager really brings on the table. The benefit is, imagine for a moment, for whatever reason, this repository gets killed. Since I had an exact same copy of that repository, I can easily recreate it with everything inside it, all of the branches, all of the tags, all of the commit messages, so on and so forth. This was not possible in a centralized system. In a centralized system, everybody is operating from the same server. So if the server dies, these guys are not able to work. In this case, the development team is still able to work, still able to commit, still able to do everything they need to do as part of SCM, and wait until the origin server is stabilized. And that origin server could be stabilized from any of these repositories, depending on who had synced up recently. All right, so let's move on and look at some of the concepts that we spoke. We've already spoken about creating a GitHub account in one of the courses over here. So if you go to my YouTube portal, go to playlist, go to Docker, and there should be a course called Create GitHub Account. If you've not followed it, make sure that you follow it, have your GitHub account. Once you have your GitHub account, log in, come to the dashboard, click on New. Here's where you're creating a remote repository. So if I go back to my painting over here, we spoke about origin. Origin is what we are trying to create now. And remember, origin is most of the time Git administration work. So Git administration work is you create repositories over here, you create users, or basically assign rights to users to use a specific repository, and you do several other administration work. You could even do merge and conflict resolution and so on and so forth over here. Okay, but remember, it's Git administration. While you're working in any organization, there will be several tools that you'll come across. Again, when it comes to tooling, you need to understand the exact same thing. What problem is it trying to solve? So if it's solving a problem of Git administration, you're going to hear names like GitHub, GitLab, Bitbucket, so on and so forth. So the role that they're going to perform is Git administration work, remote work. In this particular course, we are looking at GitHub, but you should be able to follow along and do exact same thing, no matter it is GitLab or Bitbucket. So what we will do is we will go to the dashboard, click on new repositories and give a name. So let's say my first repo. You want to make it public. If you want to give a description, feel free to do that. You want to initialize it, feel free to initialize it with a README file. I'm not going to do that. I'm just going to say create repository. As soon as you do that, if you do not initialize it with a readme.md, you directly get commands over here what to do. So it says quick setup if you are done this kind of things before. Get started by creating a new file or uploading an existing file. We recommend every repository include a readme.md. So we'll look at readme license and git ignore in a short, but let's look at this. It says echo some text to readme.md, and then it's doing a git init, git add, git commit, so on and so forth. Let's move down. If you have an existing repository from command line, do this: git remote add origin, git push -u. We do not have an existing repository, so we will not do this. What we will do is, you don't even need to read all of this. I will go to my repository and I will download using HTTPS. We will see in the future course how to set up SSH, but for now, download it using HTTPS. So click this little thing over here to copy this content, or you can even select it and copy it. Go back to your workspace, open up a terminal. What's my present working directory? Samir. So I'm going to create a new one called delete, because I want to delete it at the end of this course. And you got to say git clone. Git clone is the command that lets you, so if this is you over here, you have created a repository called my test repo. You want this my test repo to be brought on your local. The command is git clone. That's exactly what you're doing. Optionally, by default, when you do git clone and the URL, this is the name that will be for your folder, my first repo. Optionally, you can give a name over here. If you do not want that same name, you can change it. So what I will do is I will keep it exactly same, but I will just camel case it or title case it. Now if I do ls-lrt, I should see my first repo in title cased folder name over here. If you go inside it and do a ls-lrta, what you would see is there's a folder called .git. We will explore the content of .git later on, because that's more of advanced level. For now, what we have is an empty repository, which is a Git repository. So we can definitely, there is one command that you will continuously use is git status to check what is the status of your repository. So it says on branch master, no commits yet, nothing to commit. Create copy file and use git add to track. So what we will do is we will create a simple readme.md. So what I'll do, echo introduction to a file called readme.md. The title case doesn't really matter here, but then if you do ls-lrt to list what is in there, you would see there's a readme.md. If I do a git status now, it should tell me exactly that there's a new file which is an untracked file. In the coming videos, we're going to look at what is a tracked file, untracked file, tracked file modified, so on and so forth. But for today, just understand the very basics of it. What problem is it trying to solve? So if you see here, it says untracked files. Use git add file to include in what will be committed. So what we could do is we could say git add readme.md, enter. Now if I say git status, it will no more show as red there, it will say staged. Changes to be committed. Use git rm cached to unstage. That means it has staged it. Before we move any further, it's very important for us to understand the different compartments through which files move while it's on your local repository. So let's take a look at that. If this is your local repository, which is a .git or Git repository basically, it has at least 3 compartments. This is called your work area. This is called staging area, and this is called commit area. Okay. Whenever you create files, you work on a new file or you work on existing files or whatever, that's all happening in your work area. When you do git add, when you do this git add command, it moves from your work area to the staging area. We will see what is the benefit of these 3 compartments eventually, but today try to understand, to move from work area to staging area, you do git add. To move from staging area to commit area, you use git commit. And this is very important to understand, right? We talked about distributed Git repository. See that you're able to do a git add, git commit. So basically you'll have logs of what changes are done after you do git commit. Everything is happening in your local repository. As soon as you're ready to push your changes to the origin, the place from where you originally downloaded or cloned your repository, that's when you'll use a command called git push. So there are 3 commands that we are looking at: git add, git commit, and git push. So let's go back now. What we did was we did git add over here, git add and the name of the file. We did a git status, it told us that it's in staging, and if you want to unstage it, you can do git rm -- cached and the file name. So if I want to unstage it, that means I want to bring it back from staging to work area, I can do git rm -- cached and the name of the file. Now if I do git status, you should see it in red color. It's untracked. Awesome. So what I will do is I will do a git add. If you had more than 1 files and you wanted to add all of them, you could do a git add dot. It will add everything that's in that folder and all of the subdirectories. Now if I say git status, it should say it is in the staging area. Now if I want to move it from staging to commit area, the command is git commit. But with git commit, you have to tell what that commit is all about. So it's very important to understand that you're creating a commit snapshot of more than one file. So although we are going to just have one file in this particular commit, but technically you can create a snapshot of more than one files in a single commit hash. So if you do git commit -m my first commit, -m is message, and then you put the message my first commit. So it tells you, please tell me who you are. So I have not set up the config for, and this is the first time that we're using Git from here. So what Git needs to understand is who is it that's committing it. So since we have more than one developers who are going to be committing it, it's very important that we set details of who is committing it. So what we will do is we will pick up this from here, we'll paste it, and I will put in my email address. Same thing I'm going to do from here. I'm going to stick in my name. Then you can do git config global list to get the details of what is saved. While we are here, let's also look at, well, I'll leave this terminal over here. I'll open up a new terminal. And then if you look over here, let's go to the ls-lrta for hidden attributes basically. And then if you see, there should be something called as .git config. So if you go inside .git config, cat.git config, you will see the exact same details what you just added. So if you didn't want to remember the long commands git config global user.name and user.email, you could directly create this file called cat.git config in your home directory and add in these details. Okay, let's get out of here and let's do exact same command that we were running earlier that failed. So git commit -m my first commit, and now it says one file changed, one insertion, create mode, readme.md. Now if I do git log, so git log is a command to see what commit or commits have been done in the lifetime of this repository. So there's only one commit done in the lifetime of this repository, and the message was my first commit. So say for example, after pushing this commit over here, I'm happy with it and I want it to go to remote. At the moment in the remote, so over here, there's nothing, right? It's empty repository. You see the commands to work on that repository, but there's nothing, there's no readme.md. What I will do is I will do a git push, and it's asking me for my username. So it has pushed the changes like how we saw over here. It has pushed the changes from here to the remote, that is GitHub. Now if I go to GitHub and refresh, I should see that file. So you see the file readme.md. All right, let's look at another scenario. Another scenario is I worked on it, I pushed the file. What if there was another developer who's working on it? So to simulate that, what we will do is we will make a direct change over here. And I would save it. Now what I will do is I will go and run git status. It says on branch master, your branch is up to date with origin master, nothing to commit. So it doesn't know yet that there's a change in the origin. To get the change from the origin, you run git fetch command. So git fetch command brings all the changes from the origin to your local, but does not merge it into your work area. So if I say git status again, it says your branch is behind origin master by one commit. If you have to see what is that, what you could do is git log master, or we could do a git diff. What we're doing with this command over here is we are saying, show me the difference between master branch. Master branch is my current branch. We haven't talked about branches, and that's what we will do now. But just understand for the clarity of command over here is git diff master dot dot origin master. So I want the difference between master and origin master. The difference is this. So we have added, this is a test repository created to demo capability of Git. Okay. Since we talked about branches a little bit over here, so what we will do is we will run a couple of commands to see the branches. So I'm going to clear this and I say git branch. As soon as I say branch, git branch, it shows me a name with a star next to it. So this master is your branch in your local, and when you say origin slash master is the master branch on GitHub. It's the master branch on GitHub. We will look at how to create branches, how to hop onto branches, how to push a branch, how to pull changes for a specific branch. We will see all of that, but that would be categorized more under a moderate user or a medium level user of Git. So we will not look at it right now. Right now, you just focus on one branch. Be comfortable with very basic commands like git add, git commit, git push, git fetch, git pull, git merge, so on and so forth, right? And git diff and git log. Okay, so we did a git fetch, we did a git diff, and we came to know what the difference is. What we can do is we can say git merge whatever change is brought from origin master to master. We are already on master. We want to merge the changes from origin master into master. So I would have to say origin master. So it says one file has changed. Now if I go in and cat readme.md file, you would see that new change. We indeed see this change over here. Awesome. So that was about git fetch. Before we wind up for the day with the basics of Git, we will do one more little change over here, and we'll say this is second commit. We'll commit this change, and this time we'll say git diff master. It doesn't say, it doesn't show me any change, right? Because we haven't done a git fetch. And this time I don't want to do a git fetch and then do a git merge. I'm confident that whoever is doing a change on the remote is doing it right. So I do not really worry too much about conflicts. If there are conflicts, it will show me. So what I will say is git pull. Technically, git pull is equals to fetch plus merge. That's what it's equal to. So instead of doing git fetch first and then doing git diff, what I will do is I'll do a git pull. For now, you can ignore this message. It's just a warning. We will look at it later on in the upcoming videos. If you do cat readme.md, you see that the message has been fetched and it has been merged into readme.md. That's it for today, guys. I hope you enjoyed.